So these are the meters which is used to measure voltage, current and power. Suppose if you have a voltage source and if you want to measure the voltage of this source, then what you are going to do? You are going to connect a voltmeter across the voltage source, and this voltmeter will have a will have a scale, will have a scale. Okay, on the scale we are going to have the readings like 1, 2, okay, 3, 4, 5, like that. The scale is divided, and we have a pointer. Suppose the pointer will deflect and show a number. So based on the number shown, we are going to conclude that the voltage is 3 volts. The voltage is 3 volts because the pointer is showing 3. Likewise, the same, this is voltmeter V. Similarly, we have ammeter. Okay, ammeter will have the scale like this, as if voltmeter is having 1, 2, 3, 4, 5, 6, 7, 8, like that. Suppose the pointer is showing 4 means this meter is connected, suppose in series with any element. Okay, and if this ammeter is showing, this pointer is showing 4 means, 4 means, that means 4 amperes of current is 4 amperes of current is flowing in the circuit, in this line where the ammeter is connected. Similarly, if you have a voltage source and some current is coming from that voltage source, and if you connect a wattmeter, then what if you have a scale like this on the wattmeter also, and suppose this is the deflection, and this is 1, this is suppose say 2, this is 3, and this is 4. That means it is showing 4. That means this power source, the source is voltage into current is 4 watts. Voltage into current is 4 watts. Okay, so that means when voltmeter is connected, we are going to measure the voltage of the source. If you connect the ammeter, then you are going to measure the current, and if you measure connect the wattmeter, then you are going to measure the power. Okay, power in a single phase, because voltage and current are present. So how many parameters are input to this voltmeter? One parameter, that is voltage. Voltage is input to the voltmeter. Current is the input to this ammeter. And for this, how many inputs are there? Voltage, and current. So how many parameters are input to this meter? Wattmeter, voltage and current. So 2 parameters are input to this wattmeter. That's why in wattmeter we will have one coil to hold or to take the current input, and one more coil with some resistance, okay, with some resistance, and this coil will hold the voltage. So 2 coils are there, 1 and 2. Okay, in a wattmeter, how many coils will be there? 2 coils. One is called current coil. One is called current coil, and two is called pressure coil. Two is called pressure coil. Okay, in a wattmeter, how many coils are there? 2 coils. One is called current coil, and second one is pressure coil. Current coil will hold the current, and pressure coil will hold the voltage. And finally, the deflection in the pointer, is the product of these 2 volt and ammeter readings. The deflection because of this volt and ammeter readings. So When we are going to connect a wattmeter, you are going to connect four terminals M, this is L, this is C, and this is V. So the wattmeter will have four four terminals. Four terminals. See here, if this is your voltmeter, how many terminals this voltmeter will have? Only two terminals it will have. Suppose this is the voltmeter. Okay. So how many terminals it will have? It will have only two terminals. Okay. This is one terminal. Okay. This is one terminal and this is the second terminal. Two terminals. Okay. Suppose if you want to measure the voltage across this resistance R, okay, then from here you are going to take one wire and connect it to this terminal. Okay, and from here you are going to take one more wire and connect it to this terminal. Okay, this terminal. So that this meter will read this meter will read the voltage across this resistance R. The voltage across this resistance. So how many terminals are there? Two terminals. Two terminals are there for voltmeter. Suppose this is your voltmeter. V. V is represented for voltmeter. Suppose if you have ammeter, how many terminals you require? For ammeter, how many terminals you require? Again, two terminals only. Because you are connecting the ammeter in series. Okay, in series with any one of the devices. Suppose if you want to know the current in this resistance, then what you are going to do? You are going to connect your ammeter here. You are going to connect your ammeter here. That means this is the input current and from the ammeter current will go. That means two terminals are sufficient. Two terminals are sufficient as if for voltmeter. But the function done by this ammeter is to measure the current. Okay, to measure the current. Okay, so this is your ammeter. Likewise, if you want to measure the power, so the same meter, the wattmeter will have how many terminals? How many terminals? Four terminals. The wattmeter will have four terminals. Okay, suppose this is your wattmeter and suppose this is your scale. Okay, this is your scale and the wattmeter will have how many terminals? Four terminals. What are the four terminals? What are the names given to these four terminals? So four terminals are connected to this wattmeter and these four terminals, okay, these four terminals are called M, L, C and V. MLC and V. This is your wattmeter. This is your wattmeter. Okay, this is your wattmeter. So voltmeter will have two terminals and ammeter will have two terminals and your wattmeter will have four terminals called MLCV. Always I can't represent the wattmeter like this. So what I will do, I will go for this representation. That means, suppose if I have a single phase supply, suppose R phase. So in a single phase supply, we have only one phase and second one is your neutral. Suppose if you want to connect a wattmeter in this R and N, what you are going to do? You are going to connect the current coil in series with the phase which you are going to measure the power. That means current I is coming like so. To hold this current, you will require current coil, and the pressure coil is connected from phase to neutral because phase to neutral because we are going to measure the voltage. We are going to measure the voltage V, which is between phase and neutral, called V phase. That's why we are connecting this pressure coil PC, pressure coil across the VP. Okay, so this point is called M. This point is called L, this point is called V, and this point is called C. Okay, sorry, this is C and this is V. Okay, so this is your wattmeter connection for a single phase. Okay, suppose if you have a three phase, and if you want to measure the power in the three phase, in a three phase, how many phases are there? Yeah, please tell me. How many phases are there? Three phases called R, Y, and B. So now how to connect your wattmeter? Suppose if you want to connect a wattmeter, okay, here the current coil of the first wattmeter, this is W1, is connected to R phase. Okay, is connected to R phase, and it will read the current in the R phase. It will take the current in the R phase. Similarly, you are going to connect the current coil of the W2, okay, W2 to the Y phase, and this will read IY. And suppose if I have one more wattmeter W3, then I want to connect in B phase, and this will read IB. This will read IB. Now, suppose this is the load which you are going to supply this current. Current will come from this R phase and go into this load. Okay, go into this load. Suppose say this is a star connected load. Because it is a star connected load, what you are going to get? You are going to have a neutral point. Okay, a neutral point. Suppose, let me take it as a neutral. This is N. The common point is called neutral, and one wire I am going to bring it out called neutral. Okay, one wire I am going to bring it out. So this current should go into this R phase, right? Should go into this R phase. So IR should go into the R phase, and similarly IY should go into this Y phase. Okay, should go into this Y phase. Okay, so what is the current? I have to represent it as IY. Okay, it is going through current coil of the wattmeter 2. Similarly, B phase current IB should go into this B phase like this. Okay, so now IR, IY, and IB are going into this R, Y, B of load. This is R by B of load. Now if I want to connect the pressure coil is connected between phase and neutral, right? So this is your pressure coil, and what I am doing, I am going to connect it to this neutral point. I'm going to connect it to this neutral point. Similarly, the second wattmeter will have its own pressure coil. Okay, its own pressure coil, and this we are going to connect it between phase and neutral. Similarly, W3 will also have its own pressure coil, and this is also connected between phase and neutral. Neutral is the common point for all the three wattmeters. So this is the current coil of wattmeter 1, this is the current coil of wattmeter 2, and this is the current coil of wattmeter 3. This is the pressure coil of wattmeter 1, this is the pressure coil of wattmeter 2, and this is the pressure coil of wattmeter 3. Now wattmeter 1 will read the power consumed by this R phase. Okay, so this is read by W1. Similarly, the power consumed by Y phase is read by W2, and the power consumed by the B phase is read by W3. So if I want to know the total power consumed, PT is equal to W1 plus W2 plus W3. So how many meters you are using to measure the three-phase power? You are using 3 wattmeters. How many meters you are using for measuring the single phase power? how many meters you are using to measure the single phase power? You tell me how many meters you are using? Hello class. How many meters? 1 watt meter. Here 1 watt meter. Okay, 1 watt meter. Okay. Now for a 3-phase, how many watt meters? 3 watt meters we are using. 3 watt meters we are using. Now my problem, I got one problem now, because suppose this is your R phase. Okay, this is your R phase, and the load is situated at, suppose say the load is situated at somewhere around 100 kilometers. The load is situated at 100 kilometers. That means this R phase is going 100 kilometers, and here it is going into this load. Okay, so here load is there. Here the load is there. Your R load is there. Okay, so this is the transmission line, suppose say. So it is traveling 100 kilometers and it is giving the power to this R. Now, if I want to measure the power at this end, what I will do? I will connect a current coil at this. I want to know how much power I am sending. Okay, here. Okay, so the current coil is connected to this R phase. Okay, R phase. And where I have to connect the pressure coil? The pressure coil is connected between R and R and R and I need a neutral, right? Suppose the length from here to here is 50 kilometers. Okay. Now I have to travel 50 kilometers and connect this. That means I need one more wire, long wire, because here somewhere neutral will be there. Or I have to travel from here to here and I have to connect here. That means 100 kilometers I have to travel and connect the R phase. Is it feasible? Is it feasible? No. No. Okay, it is not feasible. The current coil and the pressure coil, okay, there is no problem with current coil, but pressure coil, other terminal, M is connected, L is connected, V, C is connected, and to connect this V terminal, I have to travel 100 kilometers. Okay, so what they have done is, they have formulated a formula and said that with 2 watt meters, with 2 watt meters, 2 watt meters, okay, watt meters, watt meters, okay, we can calculate, we can calculate the total 3-phase power. Total 3-phase power. That means the power consumed in R, the power consumed in Y, and the power consumed in B can be calculated using 3 watt meters, they have said. Then you might be getting a doubt how this 2 watt meters can measure the 3-phase power. To measure 3-phase power, how many watt meters we require? As I told you in this slide, I require W1, wattmeter 1, to measure the R phase, W2 to measure the Y phase power, and W3 for measuring the 3B phase power. But what I am telling here, I require only 2 watt meters to measure the 3-phase power. Okay, how this is achieved? How this is achieved? Okay, how this is achieved? Let us see. Let's see. Suppose this is your Y phase. Okay. Suppose this is your Y phase. Okay. This is your Y phase. Okay. And this is your B phase. This is your B phase. Okay. This is your B phase. So What I told you, I have told that I need only 2 wattmeters. What I will do is, this is R phase, okay, this is Y phase, and this is your B phase. I will use any one of the phase as a neutral. I will use any one of the phase as a neutral, and instead of connecting it to neutral, what I am doing, I am connecting it to any one of the phase. I will use in this case B. So what I have done, I have connected the wattmeter 1 to B phase. Okay, B phase. Okay. So this is B phase, which is used as a neutral point. Similarly, I have this Y phase, right? This Y phase. Okay. So I will connect a wattmeter current coil to this Y phase. Okay, Y phase, and pressure coil between Y and neutral. So here my neutral is B phase. So what I will do, I will connect the pressure coil. Okay, so this is my pressure coil, and this pressure coil I will connect it to B. So this is W2. Since I am using B as a neutral path, I won't connect any wattmeter to this B. So this is the current coil of second coil, and this is the pressure coil of the second wattmeter. So I am telling that, okay, this, the power consumed in R, Y, B phases are measured with 2 wattmeters in this connection. If I connect like this, I can measure the P total. P total is equal to W1 plus W2. Okay, the whatever the power you got previously by connecting 3 wattmeters, okay, to the 3 phases, the same you are going to get it in here also. How you are going to prove it now? How you are going to prove it now? Now see here, listen carefully. This is VRY. This is, what is this? This is VRY, line to line voltage, and this voltage is VRB. VRB. Okay, VRB. Or if you follow the phase sequence, it is VBR. VBR. RY, YB, VR. Okay, so VRY, this pressure coil is connected between VRY, sorry, V, R and B, and sorry, I will write here V, R and B. Okay, and this is V, B, Y and B. Okay, so what you are going to do, you are going to calculate the voltage VRY and VRB. So no need of VRY. Only VRB and VYB are sufficient. And this voltage I am calling it as, VRN, because this is the point N. Okay, this is the point N. Similarly, this is VYN, and this is your VYB. So, clear? So how I am connected? I am connecting only 2 wattmeters, and I am using one of the phase. Here I am using B as the neutral. Okay, to connect the V of wattmeter 1 and V of wattmeter 2. This is M point, this is L point, this is C point, and this is the V point. Okay, this is the V point. Now, if this is the current in R phase, listen carefully, very, very important. And this is Y phase. So what is the angle between VR and VY? IR and IY and
120.
IG. So suppose this is IR. Okay, this is IR. and this is IY, and this is IB. Okay. Now let the load be having a power factor. Let the load be having a power factor of theta, or the current between, okay, the current between the phase voltage and phase current is, this is phase current, right? Okay, IR, this is IY, and this is IB. Okay, this is IB. Now I don't take pure resistance. What I will do, I will take a R and L combination, so that there is a phase angle between the voltage and current. Okay, phase angle between the voltage and current. Now let the voltage, okay, of VRN is making an angle theta with this IR. Okay, and this is your VYN, and this is making an angle theta with this, and similarly this is your VBN. This is your VBN. So this is making an angle theta with the B phase current. This is phase voltage and phase currents. Now from here, what is the voltage between for wattmeter 1? For wattmeter 1 is connected between R and B phase. R and B phase. So the pressure coil is connected between VRB. Okay, VRB. Okay. So how I will get VRB? VRB is nothing but VRN minus VBN. Okay. VRN minus VBN. So what is VRN? This is. What is VBN? This one. So minus VBN means it will come like this. So this is your minus VBN. Minus VBN. Okay. This is your minus VBN. So VRN plus VBN gives VRN plus VBN gives ఏమొస్తుంది చెప్పండి అమ్మా VRN మైనస్ VBN ఈ రెండు యాడ్ చేస్తే ఏమొస్తుంది this is your VRB. This is your VRB. Okay. And the phase angle between VRB and is 30 degrees. Okay. Is 30 degrees. Okay. Is 30 degrees. Similarly, W2 is connected between W2 pressure coil is connected between which phases? See here, it is connected between Y and B. So V by B is the voltage. So which is equal to VYN minus VBN. Okay.
VBN.
Yeah. VYN minus VBN. Okay. Already minus VBN is here and VYN is here. So if you vectorially add these two, VBN and minus VBN and VN, okay, what you are going to get? You are going to get VYB.
VYB.
Yeah, VYB. So you got your VYB and VRB. Okay. Now, how these voltages VYB, okay, VYB and VYB and IY. IY is the current. Okay, IY is the phase current. So what is the angle between VYB and IY? So this is 30. I will tell you how we got this 30. Okay. So what is the angle between these two? Is 30 degrees plus theta. 30 degrees plus theta. Similarly, VRB and IR. VRB and IR. The total angle is zero. So this is your 30 degrees. So this is your IR. If you want to know the angle between ERB and IR, so 30 degrees minus theta. 30 degrees minus theta. Okay. So the power is nothing but V. Suppose let us take VYB is equal to, okay, VRB is equal to VL, because it is a line voltages VL. Okay. And IR is equal to IY is equal to IL. So if I take like this, instead of VYB, I will write VL. Instead of IY, I will write IL. And what is the power formula? VL IL, cos of angle between those two. What is the cos of angle between these two? 30 plus theta degrees. Power formula is voltage into current into cos of angle between voltage and current. Similarly, VRB is VL, IR is IL, okay, into cos 30 minus theta, cos 30 minus theta, okay, cos 30 minus theta. Now you got W1 as VL IL cos 30 plus theta. Then, sorry, 30 minus theta. 30 minus theta, and W2 as VL IL cos 30 plus theta. Now you add W1 plus W2. If you add W1 plus W2, then we are going to get VL IL cos 30 minus theta plus VL IL cos 30 plus theta. 30 plus theta. Now you take VLIL common. If you take VLIL common, then what is cos A minus B? Cos A.
Cos B plus sin A sin
B plus sin A sin B.
Plus sin 30 and sin theta. Sin 30,
Theta.
sin theta. Okay. Plus cos A plus B. Cos 30. Okay. Cos 30. Tell me. Cos theta minus sin 30
Sin theta.
sin theta. Okay. So see, if you observe carefully, this term and this term will get cancelled. So what is remaining? VL, IL. Okay. 2 cos 30 cos theta. What is cos 30? Cos 30 is root 3 by 2, right? VL, IL. Okay. 2 into root 3 by 2. Okay, into cos theta. Into cos theta. So 2 to get cancelled. So you are going to get root 3 VL IL cos theta. That means the power which you are measuring with 2 wattmeters is nothing but the total 3-phase power. What is the formula for 3-phase power? Root 3 VL IL cos theta.
IL
This is the power P total formula. Or 3 times V phase I phase cos theta. Any formula you can use. If you know line current and line voltage, you will use this formula. If you know the phase current and phase voltage, you are going to use this formula. Okay. Now it is nothing but your PT. That means which is same as W1 plus W2 plus W3, which we have done in the previous connection. So here we have connected like W1 plus W2 is P total, which is same as root 3 VL IL cos theta, which is same as W1 plus W2. That means with the 2 wattmeters, I can able to measure the 3-phase power. I can able to measure the 3-phase power by making one of the phase as the neutral. By making one of the phase as the neutral. Okay, but it is not the neutral. Some current is flowing in this IB also. Okay, IB also, and here IY, here IR. Okay, these currents are flowing, but what we have done, just a simply we have connected V to this B phase and here W to V to this B phase. By doing so, what we have done, there is a small the pictorial representation that what is the angle between IR and VRB and IY and VYB, and with that we have derived two expressions for W1 and W2. Okay, and we added W1 and W2 and got W1, but W2 is nothing but your total power in a 3-phase.